Is it okay? If it's not okay, pull me aside later. Let's go over some of this stuff. You got a test coming up, okay? No problem. We can do that. I'll be here after school on Thursday if you want to come and ask questions. That kind of stuff. Are you ready to move on? Yeah? Okay, let's do it then. All right, so the first one is, you've seen this before. This is stuff we did in 7.4 part 1 even. So if I got to solve for x, can I rewrite this in base 3? 1 over 9, can I rewrite it as base 3? Right now it's 1 over 3 squared, isn't it? And how can I make it so it's not a fraction? Yeah, I'm going to write it like this. Remember? All I did was change that fraction. That's all I did right now. Okay, now what would be the next step? Yeah, it's going to be a power to a power, which means it's negative 2 times that stuff. So it's going to be 3 to the negative 2x minus 6. Okay? Now I have the same base. I can just say that the exponents are equal and solve for x. Add 2x to both sides. 3x equals negative 6. X equals negative 2. You've done that a bit. Hopefully you're pretty comfortable with that so far. If not, practice. All right, let's do the next one. How would I start that? Let's write them as base 10. Okay? So 100 as base 10 is 10 squared, isn't it? 1,000 as base 10 is 10 cubed. Then I distribute the powers, basically. Power times power is... So this is going to become... I'm just going to get rid of the bases and distribute in the same step. So I'm going to have 14x plus 2 equals 9x minus 6. Do you all see what I did there? Got rid of the bases. Because they're the same base, I'm going to do that anyway. And did 2 times 7x plus 1 and 3 times 3x minus 2. Set them equal to each other. Because the bases are the same. And now I can solve for x. 5x equals negative 8. Wait. Are you... Oh, you're talking food. Did I lose anybody on that? No? Did I lose anybody on that? Be honest.
From the beginning, so yes.
X is approximately 0.155. Okay? This one here. You want to isolate this part right here. That's your ultimate goal. You want to isolate that part right there. So it's like solving an equation. You add 7 to both sides. Equals 20. That would be my first step. Add 7 to both sides. And then what do you think I would do next if I'm going to isolate that part? Divide by 4. E to the negative 0.3x equals 5. Do I take the log of E or do I write it as what? ln. Now I'm going to do this step right here. Okay? I can do it. It's perfectly legal. Instead of log, I'm going to write ln because that's what I do when I'm working with E. So up here, this is where we're at, kind of at this step here. Then what did I do? Brought the exponent in the front, right? Oh, what's ln of E? ln of E is 1. Okay? So this is basically just 1. And then what would I do to finish this problem? divide by negative 0.3, because ln of 5 is just a number. So you go to your calculator, do ln of 5 divided by negative 0.3. And x is approximately negative 5.365. Yeah? These are super easy. Take a look. What do you think? Can I divide both sides by log 4? And then they just go away, don't they? I can just boom, boom. If I divide both sides by log 4, they go away. And I've got 2x plus 8 equals 6x minus 12. If I divide both sides by log 4, they're gone. So then I'm just going to say, okay, if I solve this just for the sake of time, I'm going to say x equals 5. How about this one here? What do you think you would do? Yeah, divide both sides by ln. And you just have 7x minus 4 equals 2x plus 11. When you solve, you get x equals 3. Okay? All right, so these are a second set of problems you're going to get, stuff like that. All right, next thing. Solve. When not sure what to do, try rewriting an exponential form. So let's try rewriting an exponential form and see what that does for us. I don't know what else to do right now. So it's going to be this, 7 squared equals that. Oh, look how pretty that is. I rewrite an exponential form. I can work with that. 49 equals 3x minus 2. When I solve for x, I get x equals 17. I think you all know how to solve an equation for x, so we won't work through that completely. How do you feel about that? Okay, same thing here. Rewrite this in exponential form. It's going to be 2 to the 5th equals x minus 6. I don't even need the parentheses. Didn't have to write those. 32 equals x minus 6. What does x equal? Add 6 to both sides, 38. Okie dokie? Way easier than you think, huh? Okay, it gets better. All right, sometimes you need to check for extraneous answers. So what you got to do here is, if you're looking at log functions and you have a plus here, you should probably think about the properties and condense. Okay, and let's see if that helps. Condense. So I'm going to write it as log of 6, 3x times x minus 4 equals 2. So I condensed. Because it was addition, I made it multiplication. Then I'm going to rewrite in exponential form because I really don't know what to do with this right now. So this is what it would look like. It would be 6 squared equals all of that junk. Oh, does anybody know where we're heading here? They're quadratic equations, which means we're going to factor eventually to solve for x. So I have 36. I'm going to distribute the 3x. Remember, my goal is to solve for x, so what do I need to do? I have to set it equal to what? 0. So minus 36. Probably the easiest thing to do is remember, look at each term. Can I divide something out? Yeah, let's do that. Now I have a leading coefficient of 1, so the easiest thing to do is just look at the end term, negative 12, factors of negative 12 that add to negative 4. Can you think of it? Factors, negative 6 and 2, right on. So x is equal to 6 and negative 2, and we have to check for extraneous. Now that's what this looks like. Okay. What you do is you take your x value back up here, and let's write it down and see what it looks like. So I'm going to take my x value back up into here, and that makes log 6 of 18 plus log 6 of 6 minus 4 is 2. Does that equal 2? Do you know how to do that? Can we condense? Yeah, let's condense. Log 6 of 36. Does that equal 2? If I rewrite it, 6 squared equals 36. This is a true statement, isn't it? So that 6 works. Let's just see what happens with negative 2. Log 6 of negative 6. I'm guessing I'm going to have a problem here. Have you seen any negatives at this point? Negative 2 times 3 is negative 6. Let's just stop here. Let's do change of base like we saw yesterday and see what happens when we enter this on the calculator. So if I do this, log of negative 6 divided by log of 6, this was change of base from yesterday. I'm just doing this part. I want to see what the calculator tells me. What happens when you put in log of negative 6? Well, it doesn't say error. It actually says something. Look, what's it say? Non-real. You can't do it. Can't do it. So this is a non-real answer, so this one is extraneous. Okay? Doesn't work. We're not going to do this one. It's the same as this one. But what I want you to realize is when you have to factor, you will always have an extraneous solution with log functions. When you have to factor to solve log functions, you will always have an extraneous answer. I'm trusting the book in that. I can't say I've done enough to be sure of this, but that's what the book says. So. Okay?